Yeah, welcome to the kind of off-chain panel, right? We talk about Plasma, state channels, and you as developers most likely, when the question comes to how to scale your application, the answer is easy, just go off-chain, use Plasma, state channels, something like this, and then you might not know how to actually do it. Maybe we can bring some light into this today. Maybe you guys introduce yourself briefly, like your name, what you're working on, how that might help developers.
Okay, so my name is Augusto. I'm working on the Radar network. I have been working on the Radar network for 3.5 years. The Radar network is a payment network, so we are doing payment channels and not necessarily state channels. So the Radar network is really good if you want to make payments and you don't want to wait for the blockchain to confirm the payments, and you don't want to pay for the fees, right? So that's the scaling solution that we are offering. We are offering a scaling solution for payments.
Yeah, so my name is Tom Close. I'm the founder of Magmo, which is a state channel research and development company. So our first project has been the Force Move game framework, which is a framework which you can build very simple state channel applications on. And I'm going to be talking about that more this afternoon.
Hey, my name is Alexander. I'm with the Gnosis, and I'm a researcher over there, and we are building exciting decentralized exchanges using batch auctions.
Cool. Hi guys, my name is Johann. I'm with a team that is called Parsec Labs. We focus on plasma research, and our target industry is kind of gaming as well. Specifically, we're looking at how to enable smart contracts to run on top of a second layer solution like Plasma.
Okay, thank you. Maybe let's start. What do the two second layer solutions that we're talking about today, state channels and Plasma design, have in common technology-wise? What do they share some building blocks? What would you say?
In my opinion, the biggest thing they have in common is that they're scaling solutions, but how it works in the tech side, they have like huge differences. For instance, if you have like in Plasma, you need to wait for the operator to actually publish the hash of the current latest state in the chain, so there is interactions when you're using Plasma with the main chain. And state channels, by definition, they should not go on chain, right? You're avoiding the chain for all costs, and I think that's like one of the biggest differences between these two techs.
So, okay, so like building blocks, do they both work with kind of deposits or challenge?
Yeah, so I mean, I guess I would say that there are a lot of similarities between how the like high-level pattern of how state channels work and how Plasma works. So some of those features they have in common is both of them require you to deposit some funds into a contract on-chain. Both of them involve then some off-chain agreements being sent back and forth, messages, signed messages being exchanged between some participants. And then each of them has I guess like a timed checkout process. And that timed checkout process is kind of important to making the whole thing work, because that's your ability to like challenge that something bad's happened off chain. So it's like those three things: the deposit beforehand, the messages off chain, and then at the end this like time period before you can check out your stuff to enable someone to challenge what you're trying to do. I see those as like the three things which are the main similarities between state channels and Plasma.
Exactly, I completely agree. And another thing that we share, that we all think our technologies are very safe, that they basically have the same security as the root chain. But indirectly, we all make the same security assumptions, namely that transactions are not being able to send it on the Ethereum root chain, and that participants can get online. So we take a liveness assumption to these technologies.
Yeah, those are good summaries. I would maybe add to kind of create a distinguishment to other solutions is that it is not just like bridges to other data structures like other blockchains, because you have these crypto-economic games that secure them. And that's what gives you the security of the Ethereum miners or of your host blockchain security, and you don't need to spin up a set of validators or create a proof-of-stake network to have all the security from this design model, kind of.
Okay, so you would say there's, if you want to have a high-level metaphor, that would be there's kind of the judge and deposits on the blockchain, and off-chain we have signed messages agreements between participants which they can enforce on the blockchain if necessary. Something like this? Okay. Maybe then let's talk a bit about trade-offs. So there's like two different technologies that are mentioned often, state channels, plasma. What do you say are the trade-offs between them?
Yeah, so for me, like the biggest trade-offs that you have with state channels is that you don't need to interact with the blockchain. So once you make the deposit, you open the state channel, and then you can just make the exchange of signed signatures, signed messages off-chain, and you don't need to publish that data to the main chain. In contrast to the plasma, where you have to actually update the state on-chain. So there is some interaction with the blockchain. I mean, the consequence of this is that on Plasma you don't have necessarily the same finality guarantees as you have with state channels, because in state channels, once you receive a proof, you can just start the proof, and you are for sure guaranteed by how the smart contracts work that you can use that proof on-chain, and that means it's final once you receive the message. In contrast to Plasma, that you actually need to wait for the confirmation of the block hash that's published by the operator.
Yeah, and yeah, for sure there are differences in the finality that you achieve between state channels and plasma. For me, the biggest difference between them is state channels. A state channel is an interaction between a set of parties that were fixed at the beginning of that interaction. So like, if you've got an interaction between 3 parties, and you know who those 3 parties are going to be up front, and people aren't going to join that group of people, and people aren't going to leave, then a state channel is a good solution. If you need like an off-chain agreement where people can be added to your chain and then removed, then Plasma is a good fit. So that's like one key difference. Like with state channels, you need to know who's involved beforehand. State channels proceed by complete consent between that group of individuals. So there is no good way to add new people and remove them after the fact.
Yeah, that's to add to that, I think when you want to use state channels, you kind of have to come and start on the main network, right? So you need to be able to send a transaction into the state channel to say, hey, I'm here, I'm one of these set participants. What you can do with Plasma is that people come at any point of time, so they might not actually know that the Ethereum main network is somewhere. They might be completely new to the blockchain space. They create a key and they can participate in a secure network already without needing to pay gas. So they're just part of this app. And then once they kind of learn about the rest of the ecosystem, they can exit into the Ethereum main network and kind of float around. But I think that's definitely something that Plasma will maybe be good at, is to bring new people to the ecosystem.
Another difference, maybe Johann, you disagree with this one, but like on state channels, it's much, much easier to get general state channels that can also allow you to execute some smart contract logic within the state channels. And on Plasma, I think it's much, much harder.
Yeah, that's definitely a topic that I spend a lot of time with. And last year, my team, or this team I'm working with, has built a decentralized poker platform with state channels and trying to execute the poker logic in those state channels. And the issue is, of course, what if you're on a mobile, you're traveling on the train, and then you have no connectivity, the whole kind of app state. If one guy goes offline, it becomes difficult.
I would actually say that too. Like, state channels have the capability to do these like arbitrary protocols, but it's not like taking your smart contract that was running on chain and just putting in a state channel and having it work. You do need to kind of like design your interaction with the state channel in mind. So yeah, I think that's an important thing to bear in mind. Like, it's not just like take it and it works. there is like a lot of stuff to be done.
There's this term, generalized state channels. So what is actually generalized in that state channel? Like, it's not the computation, right, as you just said?
So, I mean, I think, so the term generalized state channels isn't completely well defined, but to me it means like a state channel where you can run an arbitrary computation. And in some way it's building on that metaphor of being able to take your contract and just put it in a state channel. But actually it isn't quite that simple. There is more to it. It's more like a framework for building arbitrary state channel interactions rather than a framework for taking an on-chain contract and being able to run it off-chain.
So I just published a post on Eth Research with the title, "Why Smart Contracts Are Not Feasible on Plasma." So we kind of have these same problems or limitations that we can't just take any smart contract of the main network and put it on a Plasma chain because of these problems with data availability and the fact that actually everything kind of runs somewhere but not on-chain.
Yeah.
There's just very easy ways to grief and attack and stuff like that. And I think the point where the research currently is more at the state of figuring out what is possible, what kind of smart contracts can we kind of put into these off-chain venues of execution, and which ones can we not.
Yeah.
That's quite interesting. Can you give some examples of applications that you think are better built on top of state channels and others just might really benefit from Plasma design?
So I think Plasma is great for decentralized exchanges, just because new parties want to join in and add their liquidity. Plasma is great for some kind of decentralized Reddit. And yeah, there are many other more variants of these ones. But basically, all the time, if you need that some other participants can join in, then you definitely should build on Plasma.
From the gaming world, maybe not gaming, entertainment. Think of casinos or something like that, where you basically, deposit some money and then you send it around 1 billion times between kind of the same set of participants, and eventually someone withdraws it. That's a great use case for something like that. And then if you can put logic on top of that and have fair tournaments and games and all these kind of things, it becomes interesting. In general, if you just kind of create sort your transactions on the Ethereum main network and you say those transactions are high frequency but low value, and these transactions over here, they are low frequency but high value, then you definitely know that once the gas price goes up, the first category is kind of pushed off the chain, right? And our project, we're kind of trying to create a public venue where these transactions can have a home, and to distinguish the different use cases that are good for that.
Yeah, so for state channels, I think they're really good for fungible tokens, where you need to make micropayments or frequent payments for streaming APIs and that sort of applications, and obviously payments, right? I think these are the main use cases.
Yeah, I'd agree with that. So state channels' sweet spot is a small number of participants, because they progress by complete consent. You basically need to get everyone's signature to progress the state. So if you get up to 9, 10 people, you could imagine that begins to get cumbersome. One person missing means everything grinds to a halt. And so having I imagine state channel applications will their sweet spot is 2 to 5 or 6 participants. One of the interesting things is to come back to that question of what are state channels good for, what sort of things can state channels not do? And there are certain things which are hard to do in a state channel. So one of the things is the concept of time. If things are dependent on time, that's a little bit hard in a state channel, because in a state channel, the only notion of time we have is the time that we all agree on. You can't, in general, challenge on time. If I give you a state and say I gave it to you at 12 o'clock, and you don't say, yeah, I agree, by the time I take that to the chain, it might be 10 past 12, and there's no way the chain can adjudicate whether I gave it to you at 12 p.m. or not. So that is one category of things which you have to think really carefully about. It's not impossible to do that in a state channel, But those sorts of games that involve time, you have to basically have different designs about when you're trying to bring them off-chain. So yeah, that's one example of things which become harder in a state channel, I guess.
Okay, so say if we would compare them on the dimensions of latency, decentralization, throughput, could you give some rough comparisons? Where they're equal, where one is significantly better than the other one?
I don't know. I think the throughput is really something that depends on the app. And if you are building a plasma chain or a state channel for one specific app, you can run it in a pretty much centralized fashion, right? Because you just need this operator or something. And the users that use it, they still have the security of the main network. So you don't need to create decentralization there. So you can run a lot of computation. But there is a limit, of course, because by design, users can exit at any time. And if there is an attack on the Plasma network, all users, all the billion users you have on your Plasma chain might want to come back to the Ethereum main network. And then it's kind of an issue. So you don't really have capacity issues at running the chain, but once you want to exit the chain, then you need to think about scalability of the main network. And what we don't want to do is people that attack the Ethereum network, we don't want to give them even more money they can harvest from like Plasma chains if they, are successful at spamming the main network.
Yeah. Regarding centralization, I think the biggest difference is that when you have a Plasma, you actually need to have the operator. So that's like one single point of failure. That in contrast to state channels, you don't have a single point of failure because it's like a network and each single node controls their own state. So it's a little bit more centralized in that sense, even though that you don't trust the operator.
Yeah, although later on in later versions, we can also make Plasma chains with many operators. It's just that currently it's much easier to have this one central guy. And just because Plasma is designed in such a way that if this one guy behaves badly, we are still all safe. We just rely on it these days.
So yeah, I mean, state channels, your throughput is limited to how quickly you can sign and send messages. One of the nice properties about state channels is that your storage space is bounded. So like, as we progress the state more and more and more, you don't need to keep the entire history of all states. You only need to keep the most recent state. So it's like order one storage. And as far as I understand, that's not the case with Plasma. As the Plasma chain gets bigger, you need to store more, I think.
Yeah, there's this arbitrary kind of period that the first implementations have set, which is 7 days. And you want to come back every 7 days and kind of, we're talking about the Plasma Classic kind of variant here. You need to come back every 7 days and make sure that, the Plasma chain is still liquid and there's data availability. Otherwise, you should exit. And only if you check every 7 days, your exit will be on time. Otherwise, you lose your money, right? So, and in this period, of course, you need to maintain a lot of data, or at least a checkpoint. So you could say it's kind of bonded to these 7 days, the amount of data that you need to verify. But yeah, you need to keep a checkpoint.
Alex, you said something interesting. You said it's not centralized necessarily because you can just have multiple operators, which kind of run a consensus protocol. But then the question is, what's the difference between Plasma and a sidechain?
The main difference is how Plasma is kind of rooted into the root chain. Like, because we are making these commitments every time, we can use Merkle proofs in order to prove exactly what happened on the Plasma chain very easily. And this kind of gives you all the security later on.
Okay, is this very different from, say, having two blockchains which can communicate by sending messages between each other and are able to validate the validity of the messages?
I would say it's very different in the way that if you run two chains and you want to get out of one of the chains, you need to be able to send a transaction on that chain or interact with it. And in that way, Plasma is very similar to state channels, that you don't need to know anything about the Plasma chain to be able to exit. You just submit your exit. and I don't know, the client crashed or the company went offline or anything like that, you can get out anytime without even looking at the data structure or on what's happening on the Plasma chain.
Okay, cool. For the developers, is there something they can use right now? Just download, use it as a building block for their applications today?
For Plasma, I think there's nothing really in production these days, but we have plenty of prototypes, and I encourage everyone to try it out.
And to add to that, there is kind of 4 good, solid implementation. I think BankX or MisaGo, one more, and then of course ours. But it's at this state where conceptually it's sound, and we know what the security assumptions are. We constructed exit games for every edge case that we can kind of see. But it's in the state of, how do you say, like smart contract implementation and backend implementation. There is no user experience designed for it yet. So we don't have wallets that are plasmified in the way that they notify you if you haven't been online for 7 days or something like that. There is no EIPs that define how there is a general exit procedure from any Plasma chain you're on. And I think what we should very much distinguish is implementations of state channels and Plasma chains that are specific to one project. So you might use MisaGo and you don't know there's Plasma underneath, but you have this option to exit. But there can also be infrastructure that is public and everyone uses it, like the Ethereum, the Bitcoin Lightning Network is a public infrastructure, right? And everyone can send payments on it. And in the same way, there can exist a Plasma chain that everyone can use to do payments or deploy contracts on. This we don't have yet. So there's just specific projects trying to implement this design concept Plasma for their apps.
Completely agree. And one additional point, like even the research has not yet really settled on, yeah, this is a really good solution. I mean, we started with a minimal via Plasma, went over to Plasma Cash, Plasma XT, Plasma Debit, and now we have the more viable Plasma. And like from all these iterations, you can see we're improving the technology still in research pretty much. And yeah, for us companies, it's hard because if you're working on such a moving ground, you kind of need to update all your thoughts and everything kind of on a not monthly basis.
Yeah.
But as far as downloading software and starting using it, did you say that you guys can use Raiden and micro Raiden? It's working really good.
Yeah. So okay. With payment channels, obviously there's Raiden. There's also like a payment channel implementation a team called Connects are working on, which uses a virtual channel, which is like a state channel concept. For state channels themselves, there isn't a lot out there beyond toy code at the moment. So the L4 counterfactual team will be releasing code in the next couple of months, showing how their stuff works. Magmo, so at Magmo we've released the Force Move Game framework, which has some examples online. You can check out the library and like build your own games with it. And in the next week, we'll be open sourcing an in-progress project where we are building the game of rock, paper, scissors on top of that framework, as in with a complete end-to-end user experience. So if you're interested, you can check that out. It's at the Magmo GitHub.
Okay. Don't know if the audience now knows whether they actually should actively already at this point in time look into these technologies to build their app, or should they just keep on prototyping what they've done before on the blockchain? Maybe also related to this question, what do you think, how much harder is it to build off-chain instead of just writing smart contracts which are deployed on-chain, say by a factor of 2, 3, 4?
Yeah, I think it's way more harder because you actually need to think on how you're going to make sure that the state that you're producing, it's always a valid state that you can actually use to settle on-chain, and that adds a lot of constraints to how you actually make the state changes for your application. You cannot just like write normal code, you need to write code that makes sense to use in a state channel. So I think it's considerably harder to make a state channel.
Yeah, I mean, in many ways, that's what the Force Move Game framework was about. It's trying to make it easy for people to write these off-chain games and interactions, because those require a different way of thinking. It's more thinking in terms of like states and state transitions. And so what the force move game framework gives you is it's a way of defining a set of states and a set of valid transitions, and then having the framework take care of all like the off-chain challenge and that sort of stuff for you.
Completely agree. Most of these points, they can be really copied over to Plasma. There we have exactly the same issues. We need to build this additional infrastructure, the off-chain infrastructure, many services around that this, I don't know, maybe a factor of five times more effort, something like this.
I agree with that. And a general takeaway from building anything on the blockchain was always, even with smart contracts, is that you only put the core business logic on chain and everything else happens off chain. And just with the increasing gas prices and with these new design patterns, it becomes even more important to think that way and just isolate what is really important for your app and put it either on chain or, if you can, into a stateful level 2 design. But always make sure that you don't put like data or unrelated stuff into the business logic of your app.
Okay, thank you. We have some questions from the audience. Some are around about what obstacles Plasma will face design-wise, security-wise, but I think that we discussed already. And then there's a question about people have been confused about the statement that in a state channel it's not open for everyone to join while a Plasma is. Is it correct that, say, in Plasma I can send some tokens to someone who's not yet participating in the network and only has to have, say, a private key to later claim them? Right?
Yes, completely correct.
And in state channels that would not work because...
So, in a way, it depends which statement you're talking about. Like, if it's a statement that you can join a Plasma chain without having any funds on the Ethereum chain, I think technically that is also true for a state channel. Like, I could find you, you could generate a private public key pair, I could create a state channel with that, with your like address. You don't actually need to have touched the Ethereum chain at all, but we could have a state channel open, and I think that is equivalent to Plasma. If it's a statement that you can't join a state channel, that does need to be clarified slightly. So state channels progress by complete agreement between a set of parties decided up front. But you can create virtual channels. So like if I have a channel on chain with Matt and Matt has a channel on chain with Bob, then I can create a virtual channel with Bob. So in some way, I've managed to join a channel that wasn't there with Bob. So I've like managed to construct a channel off chain. So in that way, maybe I've joined a state channel, but you can kind of think of it as like I've created a new state channel which also progresses by complete consent. And once I've created that state channel, no one else can join it. So there is a little bit of a fudge there, but like pretty much the way of thinking about it is state channels have a predefined set of participants which can't be changed during the execution of the state channel.
Yeah, just to add to that, I think like the biggest difference is that in the Plasma, you actually don't need to make interaction with the blockchain to actually get in Plasma. But where with a state channel, you actually need to send a transaction to the blockchain to actually create the first channel. I think that's the biggest difference.
Someone does.
Someone does.
Someone
yes.
does.
Someone
it doesn't necessarily need to be one person in the state channel could not do the on-chain transaction.